Hey guys, Mr. Backerberg here. In this video we're going to look at limits and asymptotes. So when we're looking at end behavior asymptotes, consider this big long rational function. What we're going to focus on are the powers on top and the powers on bottom. So n is the highest power on the numerator of our fraction and m is the highest power in the denominator. If the power on top is smaller than the power on bottom, then we're going to have a horizontal asymptote along the line y equals 0. If the powers are exactly the same, then we're going to have a horizontal asymptote again, but we're going to make a fraction out of the leading coefficients. So a sub n is the leading coefficient on top, and b sub m is the leading coefficient on bottom. Now, if the power on top is bigger than the power on bottom, then we've got an asymptote. But in order to find our asymptote, we need to do a little division. So we're going to take the numerator and actually do the division with the denominator. And then the quotient that we get will be the asymptote for our graph. Now, as we're looking at finding the vertical asymptotes for the graph of a rational function, we're going to focus on the denominator of our fraction, and we're going to find the zeros of the denominator. But we have to be a little bit careful. If there are reducible factors in the numerator and in the denominator of our rational function, then instead of creating a vertical asymptote at that value, there's actually going to be a hole in the graph at that specific value. Now, to find the x-intercepts for a graph, we're going to focus on the numerator, and we're going to find the zeros of the numerator of our rational function. But again, we have to be careful. Just like with vertical asymptotes, if we have a reducible factor from the numerator and denominator, then we're going to have a hole in the graph at a specific value, so then that wouldn't create any x-intercepts at that x value. And then in order to find the y-intercepts, we're going to look at checking out f of 0, meaning that we want to take 0 and plug it into our function. Now we're going to take all of those ideas and put them together as we're trying to graph out a rational function. So I want to take a look at the function f of x equals 2 over x minus 3. And because we're dealing with a rational function that has a fraction in there, the first thing I want to think about is the domain of this function. Now we need to avoid 0 on the bottom of our fraction, so it would not be safe for us to plug in 3 for our x value. So our domain is all of the x values except for 3. Now what I want to look at first are the end behavior asymptotes. So what we want to look at are the highest powers that we're seeing on the top and on the bottom of our function. So if we look on the top of our function, there aren't any x's on top, meaning that we technically have x to the 0 power on top, and on bottom we have x to the first power. So what we should be seeing is that the power on top is smaller than the power on bottom. And if that happens, then we're going to have a horizontal asymptote along the line y equals 0. So I'm going to go over to my graph, and I'm going to put a horizontal asymptote along y equals 0, so directly on that x-axis. Now the next thing I want to look at are any potential vertical asymptotes. So what I want to think about doing is factoring out both the numerator and denominator as much as possible to see if we have any factors that are going to cancel out. Now notice, because we have just the 2 on the top of our fraction, there's nothing to factor out there, and on the bottom we just have the x minus 3. So there's also nothing to factor out there. Now we don't have any factors in common on top and on bottom, so there's nothing that's going to cancel out. So then in order to find the vertical asymptotes, I'm just going to take what's left over on the bottom, so the x minus 3, and I'm going to set that equal to 0. So we're going to have a vertical asymptote at x equals 3. So I'm going to go over to my graph, and along the x value of 3, I'm going to draw in that vertical asymptote. Now what we're going to look at next in here are the x-intercepts, and what we want to do here is we want to look at the zeros of the numerator of our fraction. So I'm going to take the top of my fraction and I'm going to set it equal to 0. Now taking the 2 and setting it equal to 0 doesn't make a whole lot of sense. 2 can't equal 0. So because I'm getting a statement that doesn't make any mathematical sense, that tells me that I don't have any x-intercepts. So there's nowhere on my graph where my line will ever cross through the x-axis. And then the last thing we want to look at are the y-intercepts of our graph. And in order to find the y-intercepts, we're going to look at f of 0, meaning that we're going to plug in 0 for our x. So we would get 2 over 0 minus 3. And 0 minus 3 on bottom is negative 3, and 2 divided by negative 3 is negative 2/3. So we have a y-intercept at negative 2/3. So that's going to be just a little bit short of negative 1 as we're looking at going down on the graph here. And now we're just going to complete a rough sketch of the graph of our function. So we've got a y-intercept happening on the bottom left portion of this graph. So we're going to have this chunk of our graph that follows along this asymptote coming in from the left-hand side and then follows this other asymptote heading down. And then the other chunk of our graph is going to be up here in the top right-hand corner, again following those asymptotes that we found earlier. And we can confirm this graph by checking our answer on our calculator. Now I'm going to throw another example at you. So we're going to look at the function f of x equals 2x plus 3 over x plus 1. And again, we're going to think about the domain first in here. So we're trying to avoid 0 on the bottom of the fraction. So I don't want my x value to be negative 1, because if we tried to plug in negative 1, we would get 0 on the bottom of the fraction. Now the next thing we're going to look at in here are the end behavior asymptotes. So we're going to focus on the highest power on top, which is a first powered x, and the highest power on bottom, which is also a first powered x. If your powers are the same on the top and the bottom, then you're going to have a horizontal asymptote. And what we want to do is we want to make a fraction looking at the leading coefficients. So my leading coefficient on top is that 2, and my leading coefficient on bottom, there's technically a 1 in front of this x. So if we go 2 over 1, then we've got a horizontal asymptote at the y value of 2. So I'm going to go over to my graph, and at the y value of 2, I'm going to draw in my horizontal asymptote. Now, as far as finding any potential vertical asymptotes, again, we're going to look to see if we can do any factoring and canceling on the top and on the bottom. The top, nothing gets factored out. The bottom, nothing gets factored out. So to find the vertical asymptotes, all we're going to do is take the bottom and set it equal to 0. So we're going to have a vertical asymptote at the x value of negative 1. So again, I'm going to go over to my graph, and at that x value of negative 1, I'm going to draw in my vertical asymptote. Now to find our x-intercepts, we're going to look at the zeros of the numerator. So I'm going to take the 2x plus 3 on the top, and I'm going to set that equal to 0. I would have to subtract the 3 over to the other side, so I would get 2x equals negative 3, and then I would divide by the 2. So I'm going to have an x-intercept at the value of negative 3/2. So that's negative 1.5. So on the left-hand side here, left 1.5 spaces, I'm going to have an x-intercept. So I'm going to plot out that point right there. Now, in order to find our y-intercepts, we want to look at f of 0. So I'm going to plug 0 into my function. So I'd have 2 times 0 plus 3 on the top, and on the bottom I would have 0 plus 1. So on the top, 2 times 0 is 0, plus 3 is 3, and on bottom 0 plus 1 is 1. So we have a y-intercept at the y value of 3. So I'm going to go up 3 spaces on my y-axis, and I have a y-intercept up there. Now again, I'm going to do a rough sketch of my graph. So I've got this x-intercept happening on the bottom left-hand corner of my picture. So I'm going to follow these asymptotes and make sure I hit that x-intercept as I'm following the asymptotes. And on the top right-hand corner, I can see that I've got a y-intercept happening in there. So as I draw in my graph following those asymptotes, I need to make sure that I hit that y-intercept as well. And again, we can check our answer by graphing this function out on our calculator. Another example in here, and we're going to look at the function f of x equals x minus 3 over x squared minus 2x minus 3. Now, as we're looking at the domain of this one, the domain is going to be a little bit trickier to figure out because we've got that quadratic on the bottom of our fraction. So what I actually want to do is think about factoring out that quadratic. So if we do some sum and product factoring, this will factor into x minus 3 and x plus 1. So if we're thinking about the domain and avoiding 0 on the bottom of the fraction, I would want to avoid x values of 3, but also -1, because if I plugged in either one of those, that would give me 0 in the denominator, which would be bad. Now there's actually a little bit of simplifying that we can do with this function. Notice we have an x minus 3 factor on top and an x minus 3 factor on bottom. Now those are going to cancel each other out. But when we do that reducing, we're creating a hole in the graph. So I'm going to take that x minus 3 factor, and if I set that equal to 0, then we're going to have a hole in the graph at x equals 3. And this actually creates a more simplified version of our function. So now our function is going to say f of x equals, now we canceled out the entire x minus 3 factor on top, so we're just going to have a 1 left over. And on bottom, all we have left over is the x plus 1. Now if I think about my n behavior asymptotes, I would want to look at the powers of x on top. And there aren't any x's on top, so it's a 0 powered x. There's a first powered x on bottom. And when the power on top is smaller than the power on bottom, then we're going to have a horizontal asymptote along the line y equals 0. So I'm going to go over to my graph, and right along the x-axis, I'm going to draw in that horizontal asymptote. And then if we look at our vertical asymptotes, we want to look at the simplified down version of our function and set that denominator equal to 0. So I'm going to take the x plus 1, set it equal to 0, and we're going to have a vertical asymptote at x equals -1. So again, I'm going to go over to my graph, and at that x value of -1, I'm going to draw in that vertical asymptote. To find the x-intercepts, we're again going to focus on the simplified down version of our fraction, and we're going to take the numerator and set it equal to 0. Now 1 can't equal 0, so that means we don't have any x-intercepts for this graph. And if we want to find the y-intercepts, we're going to look at f of 0 with our simplified down fraction. So we'd have 1 over 0 plus 1, so we just get 1. So we've got a y-intercept at the y value of 1. So I'm going to plot that out. Now we said earlier that there was going to be a hole in our graph at the x value of 3, but we actually want to figure out what that point would look like on our graph. So what I'm going to do is actually look at f of 3 as far as my new simplified down version of my fraction. So I would have 1 over 3 plus 1, which reduces down to 1/4. So there's going to be a hole in the graph at the ordered pair 3, 1/4. And to show that hole in the graph, if we go over 3 spaces and up 1/4 of a space, a hole in the graph is going to be graphed out with an open circle. So as I'm sketching in this top piece, I need to make sure that I'm hitting that y-intercept. And I get really, really close to that hole in the graph, but then we have to jump over the hole in the graph with our pencil to continue following that asymptote out to the right. And our other chunk of the graph would end up down in the bottom left-hand corner, following those asymptotes again. Now we can graph this out on our calculator to confirm the graph. We're not actually going to be able to see the hole in the graph on the picture. But if you look at the table, if you look at the x value of 3, you'll notice that there's an error in the y value because we can't actually have that point at x equals 3. That's going to be it for this video. Thanks for watching.